Now we'll get into the application problems. For example 7, it says your school is building a raked stage. The stage will be 30 feet long from front to back. So that's my hypotenuse. With a total rise of 2 feet. So here's my total rise of 2 feet. Is the rake stage within your desired range? And my range is I want the angle of elevation, or the rake, to be 5 degrees. Now angle of elevation just simply means, here's X, see that? That's your angle of elevation. When you're looking at the bottom and going up, that's your angle of elevation. Let's look at what we have. Here's my angle X. What two sides do I know in relationship to X? I know the opposite side, and I know my hypotenuse. Okay, so I know opposite, and I know hypotenuse. Which trig ratio is that I use opposite over hypotenuse? So, TOA. Sine is correct. So the sine of X is going to equal 2 over 30. To find angle X, I need to do the inverse sine. First, I need a decimal approximation for 2 over 30. 0.0667. Now I can do inverse sine. My angle X is going to be, note that this question here is a yes or no question. So let's see if we're going to choose yes or no. Inverse sine, 0.0667, 3.8 degrees. You want the rake, or the angle of elevation, to be 5 degrees or less for safety. Is this rake stage within the range that is needed? Yes. A ladder, 10 meters long, leans against the building and makes a 38-degree angle with level ground. How high up the building does the ladder reach? Notice example 7 had a picture. Example 8 does not. We need to draw a picture. Here's my building. Doesn't have to be fancy, but sometimes I draw a building with horrible windows. Here's the level ground. Here's my ladder leaning against the building. That ladder is 10 meters long. It makes a 38-degree angle with the ground. Hopefully you realize this is a right angle. So I do have a right triangle. How high up the building does the ladder reach? So are we talking about the distance from the base of the ladder to the base of the building, or from the base of the building to the top of the ladder? We are talking about that distance. Next thing you decide, which trig ratio do you have? Do you have SO, CA, or TOA? In relationship to this angle, I have opposite and I have hypotenuse. I have SO. Sine of 38 degrees is going to equal X divided by 10 meters. Do I need to use inverse this time? I use inverse when I'm looking for the angle. Do I know the angle in this problem? The angle is 38 degrees. I do not need to use inverse here. I want to find this measure. I need to get rid of dividing by 10. How do I get rid of dividing by 10? I multiply by 10. X is going to equal 10 times the sine of 38 degrees. 10 times the sine of 38 degrees. We will round to the nearest tenth again. So here's the 10th place. So 5 tells me to go up 1. 6.2 meters is my answer. The ladder reaches, example 9, a tree that is 23 meters tall casts a shadow. So over here's the sun. Casts a shadow, and your shadow's on the ground. Casts a shadow that is 17 meters long. Find the measure of the angle of elevation from the sun at the time. Elevation is up, so from the ground up, what is this angle? Angle of elevation. Let's think about which trig ratio I need to use. From this angle that I don't know that I want to find, what do I know? I know that the opposite side is 23. I know the adjacent side is 17. Opposite over adjacent. So the tangent of my missing angle, I'm going to call that M, of my missing angle is going to be 23 over 17. Do I need to use inverse tangent? I need to use inverse tangent because I don't know an angle. The first thing I need is the decimal approximation for 23 divided by 17. 1.3529. To find angle M, I do inverse tangent of 1.3529. (53.5 degrees). I'd like for you to try example 10. We're back to solving a right triangle. I'd like for you to find missing sides and missing angles. I have completed example 10. I knew I was missing side A, side B, and angle A. I chose the easiest route to find angle A. I knew the two acute angles have to add up to 90 degrees. I knew that one of the acute angles is 34 degrees. 90 degrees minus 34 degrees is 56 degrees. The next thing that I did was find side A. How I found side A was I know the opposite side, and I wanted to find the adjacent side. Opposite and adjacent is tangent. So I took the tangent of 34, set it equal to the opposite side of 14, divided by the adjacent side, which I did not know. You want to always get rid of dividing by whatever you're dividing by. Therefore, I multiplied both sides by A. I had this here. A times the tangent of 34 degrees equals 14. Then I divided both sides by the tangent of 34 degrees. That left me with A equals 14 divided by the tangent of 34. If you type 14 divided by the tangent of 34 degrees in your calculator, you get this 20.8. To find side B, I put pink over here. I always use the given side, never the one that I have approximated. I always use the given side. And I know the opposite side, and I'm trying to find the hypotenuse. So I used sine. Sine of 34 degrees equals 14 divided by b. Again, I needed to get rid of dividing by b, so I multiplied both sides by b. That left me with b times the sine of 34 degrees equals 14. I divided both sides. It doesn't appear that I did, but I divided both sides by the sine of 34 degrees. So I know side b is equal to 14 divided by the sine of 34 degrees, which is 25.0. Thank you.